All right, getting the warm-up back up. Let's talk about it. Ooh, if I can, there we go. So for the first one, was anyone able to rewrite this in any way? Brian?
Okay, so I rewrote it as, so I separated the 6 to the n plus 2 into 6 to the n times 6n squared.
Times 6 squared, perfect.
And then on the bottom, I did 3 to the n times 1/3 times 2 times 4 to the n, because 2 squared is 4.
That, come on.
That's beautiful.
That was beautiful. That's beautiful. All right, so if you guys heard what Brian said, he said that 6 to the n plus 2 is the same as 6 to the n times 6 to the second, right? If you take the same base and multiply, right, you add the exponents, so you can break it apart the other way. So 6 to the n plus 2 is just 6 to the n times 6 squared. 3 to the n minus 1 is 3 to the n times 3 to the negative first. And then 2 to the 2n is 2 squared to the n, which is 4 to the n, right? And then you get all the numbers in the front and all the nth powered terms here raised to the n, and you just clean it up, right? Except this is to n starting with n equals 1, so of course you have to rewrite it to start with n equals 0 so that you can find the sum. All right, does that make sense?
Yeah.
You guys are going to do another one of these later on today. Anyone get number 2? Yeah, Dylan.
I had diverges.
It does diverge. What test did you use?
I just plugged in infinity.
Okay, and that's, do you know what test that's called?
No.
The nth term test.
It's called the Nth Term Test, right? That was very good. You are the first person today to get that one.
You just sort of like,
Dude, that's
He's
like
on fire, I
now
know.
you're a 2-hit wonder.
Okay.
No, I got
so-
another hit yesterday.
Yeah,
Oh, can we just say like you're an nth hit wonder?
yeah, there you go. So here we
The
go.
limit
When you,
and goes to
anyway, when you have an expression and you're not sure what to do, it's got a lot of stuff in it, and no one test is just jumping out at you, so you're just like, I just don't know what to do with this one. Always go back to the nth term test. The nth term test says if you take the limit as n approaches infinity of the rule, if it's not 0, the series diverges. Right? So for this one, if you take the limit as n approaches infinity, you got a L'Hopital and L'Hopital and L'Hopital and L'Hopital and L'Hopital. But once you've L'Hopital'd 5 times, right, you get a limit of 4/9. And as long as the limit is not 0, the series diverges. It doesn't have to go to infinity. It just has to not be 0.
Well,
I
he was
told him
making
why it
fun
was
of me
wrong.
because I just said it was bigger infinity minus smaller infinity over bigger infinity
And I
plus
said you
bigger
can't do
like
that.
smaller infinity.
Because you end up with infinity minus infinity,
Maybe.
and he wasn't gonna.
No, but I'll say
solve
bigger
it.
infinity minus smaller
No, but
infinity,
you
so it'll
can't
be
do that.
infinity.
Oh,
No, we've been over this. Sounds like
Yeah.
3 chapters.
Trace, you're still wrong.
okay.
Whoa.
Anyway,
Hey, he's the fourth.
regardless, all right. So either way, it diverges. Now, if the limit is 0, does that mean it converges?
No.
No, it's
Got a 50-50.
inconclusive, right? The only one that's conclusive is if it's not 0, then you know it diverges. All right, moving on. So today we are going to learn 2 new tests. We're learning the direct comparison test and the limit comparison test. So this is section 9.4. We're going to start with the direct comparison test. You know I said I wasn't a big fan of the integral test?
Yeah.
No, I told the truth. Yeah.
Could you go?
I'm not a big fan of the direct comparison test either.
Oh.
It's not bad. It's not awful. Like the limit or the integral test isn't awful. It's certainly doable, right? This one isn't awful either. But there are other tests that you can can use instead that are easier.
This is 9-4.
So this is just 9-4.
Oh, okay.
Yeah, we only do 9-4 for one day.
And this is both direct and limit.
Alright, so here's the gist of the direct comparison test. The direct comparison test says that if A and B are two series that are both always positive, and if one of them is always less than the other one, then if the bigger one converges, the smaller one converges. If the smaller one diverges, then the bigger one diverges. So, if you are smaller than a converging function, you converge. If you are bigger than a diverging function, you diverge. When I think about this with a mental image, here's the mental image I have. This is not probably a good mathematically correct image, but this is the image I have. So, if I have a function that converges, my brain thinks of something that is kind of approaching some number or some zero. So this converges, right? If I have another function that's always less than that function, then it also converges. It's forced to, because it's always below. So less than a converging function converges. If I have a function that diverges, say it's going to infinity, and then I have another function that's bigger than that function. If this guy diverges, then anything that's higher than it is also going to diverge. Does that make sense? So that kills off a whole bunch of functions. What it doesn't take care of is, what if you're bigger than a converging function? Doesn't tell you anything. What if you're smaller than a diverging function? Doesn't tell you anything, right? So it's inconclusive. So, and then for me, the reason I have a hard time is just because my brain, it's hard to prove that something's always less than something else or something's always bigger than something else. Some of them are real easy and clear cut. Some of them are not so easy and clear cut. For the ones that are easy, it's not bad. So if it's easy to see that something's always less than something else, it's okay. But then you just got to remember, all right, so if it's always less, as long as the other one converges, then the one that's below also converges. If it's always bigger, then the smaller one diverges, the bigger one diverges. All right, so this is just an open example. I'm just going to walk you through it step by step so you can see how this works. All of these problems start the same way. You get a series, and the question just says, tell us if it converges or diverges, right? So you look at this series, and you think to yourself, I don't know if it converges or diverges, but I know that it sure looks like another series, right? What does this one look a lot like?
1 over 3.
1 over 3 to the n, right?
Yeah.
So since it looks like 1 over 3 to the n, does 1 over 3 to the n converge or diverge?
Converge.
How do you know it converges?
Well, you,
R is 1/3.
no, because you do a geomet. Well, I did
Oh,
a
because you
geom.
saw what's below.
No. You can do 1/3 to the n,
Yes.
and then if you do the 1 over 1 minus 1/3, you get like a number. And
Oh, yeah,
that
all you
converges.
have to do is rewrite it without even doing the 1 over thing. If you think of it as 1/3 to
Oh,
the n,
that's
as
probably
long as
easier.
r is less than 1, it's correct, it converges, right?
Yeah.
So this is a geometric series, so as long as your r is less than 1, it converges, right? So we know that this guy, which is this guy, converges, because it's geometric. All right, so now we have to decide, is this always bigger than this, or is this always less than this? How do we know? What could help be our guide for this?
The 1 over 3.
Right.
Plug in values.
Okay, we can plug in values. So if we plug in a 1, For this one, we get 1/5. And for this one, we get, here, I'm gonna list them. So for this, oh, whoops. For this guy, we get 1/5. Plug in a 2, we get 1/11. Plug in a 3, we get 1/29. Right? Plug in a 4, we get 1/83. Right? For this guy, just switching guys. If we plug in values, plug in a 1, we get a 3rd. Plug in a 2, 1/9, 1/27, 1/81st. So comparing the terms, which numbers are always smaller, the top ones or the bottom ones? The top ones. And does it make sense when you're adding a number to the denominator every single time, that one's gonna always be smaller, right? Okay, so this series will always be less than this one, right, for all n. And that makes these easy. When it's real obvious, if you just have the exact same series, but this one's different by a constant, right, then you know this is always gonna be less. If it was different from a constant on the top, then you know it'd always be greater. So if it was something like, n and n plus 1 or something like that. So if it's just off by a constant being added or subtracted from the top or the bottom, then it's real easy to do the correct direct comparison test. So for this one, it's real clear. So then since this converges, and since this is less than a converging series, this one converges as well. So less than a converging series converges. Yes, Bill?
If you're trying to find out where it converges, could you do the same kind of geometric trick with the 1/2 plus 3 to the end, or is it totally different?
You'd have 1/2 plus, I'm trying to think of what you're saying.
Like, so for the second one, you could just do the thing where you like make n equals 0 and then a over 1 minus r.
Right.
Would you be able to do that for the top with your r still being 1/3, or would it be different because of the
It'd be different because you're completely changing the numbers that you're summing.
I was thinking if it goes to infinity.
But you're still completely changing those
Oh,
numbers.
yeah. Never mind.
Because it
Yeah.
still comes in.
All right.
So the top one, I was thinking.
Okay, so take a second, see if you can find a function that's similar. Determine if that similar function converges or not. Determine if it's less than or greater than the other function, and then make a conclusion about the original series. You okay? What, you're already in bed? Is that what I do all the time?
Well, I don't know, like, since I was in
Get with it.
So you have the one.
No, it's
Is 1/n squared?
No, you got just
It's
one.
smaller.
This function thing is in here.
No, oh, this one, oh, yeah, this one is.
That's what I did too.
Okay, this is 1/n squared. No, I haven't done 1/n
Yeah.
squared.
And then
I could do
top
1/3.
Actually, oh.
Okay.
Less than one?
Completely silent. You can still talk. A general murmur is fine. Yes. Not at all.
What if he was blind? I think you should blind. We're still. You're going so much, like the camera's focused enough.
Well,
now you're in the camera.
Oh, wait, no, this is us.
Because it was like this. And switch spots with them.
No, I said 10 seconds. No, you have to stand up and slowly.
I got the right idea.
That was really, no, that does not count. That does not count. A, and C, and B, it wasn't like, I mean, I could say that's no big deal.
Alright, what do I do?
Did you get the bonus?
No, you just stand up, turn around.
Yeah, I know, thanks for reminding me, yeah.
I don't know why he did that.
I was having a good day, Tom. Oh, good luck.
I wasn't
You're
here.
We won the peace side, so.
I just
It's alright.
Oh, you can see some.
I just got here.
Okay. Oh, hands are up. Yes, Clay.
It's only like slightly
No, so I talked to Mr. Thomas about your test today, and the test is actually, it's in 5 parts. They're literally labeled like section 1 or part 1, right? And part 1 is series convergence. So for part 1, you're given a whole bunch of series, and you just have to decide if they converge or diverge, and you have to justify it mathematically, but you don't have to name the test you're using as long as you do the work for the test you're using. So I'm going to be looking to make sure you have a valid test, like the work for a valid test that's written out. Yes, Brian?
On the AP test, will we have to name anything?
He said no. So I'm going with Mr. Thomas, he would know.
What work do you show?
Here's what I would show. I would show the function I'm comparing to, which would be I've used 1 over 3 n squared. And then, does 1 over 3 n squared converge or diverge?
Converge.
Converge by what test?
P-test.
P-series, P-test, yeah. So I would have said, compared to 1 over 3 n squared, this converges, right? Like maybe just an arrow with the word converges, something like that. And then say something like here, I think in my words, I just used words that are not custom, yeah. So what I would do is say, one,
Because it's my sister's.
converges, and then something like 1 over 3n squared plus 2 is less than 1 over 3n squared, so. Right? It's just a short number there from, yes.
So does it have to be 1 over 3 n squared, or could you just change it to 1 over n squared? It's still a comparable.
You could do 1 over n squared, because that's still a correct statement.
Alright.
Yes.
Has Mr. Thomas changed
I don't know how old the
No, the answer is no. Because the AP test started in the 60s.
How much did you vertically?
So,
Yeah, Mr. Thomas saw like the beginning.
but for the first like 20 years of the test, it wasn't called AP calculus, it was called AP math. And it didn't just have calculus, it had pre-calculus, all kinds of stuff on it, right? Yeah, so there are questions, when you look at the old test, that will say things like, here's a sine function, name the amplitude, period, phase shift,
Oh.
right?
Well, okay, but that's not.
Or you gotta test it out.
Alright.
The noise you wanted us to.
Yes, that's okay, that's all right. It just keeps the people who are watching awake. So, sometimes the test doesn't work for the first few terms. Sometimes it doesn't work for the function you pick. So, you might pick, for the direct comparison test, you might have one function that seems like the really obvious one to compare it to. And then what happens is, the one you're comparing to diverges and then your function is less, right? Or the one that you're comparing to converges and your function is greater. So sometimes the function that seems obvious doesn't work well and you have to find another function. So if you have to find another function, here's just a kind of a little word of advice, which is if you have a function that maybe you want it to be less, but say it starts out greater, but then eventually becomes less and then stays lower the whole rest of the time for all the rest of the real numbers, that's okay. So you can just start it with that n where the switching happens. So, because for convergence, we're talking about as n approaches infinity, right? If we have some finite value where it's, the test doesn't apply, that's okay. You can apply the value of the test from some different finite value of n forward, and it'll still be okay. So, for example, this one, I want you to take 1 minute, pick a function that you think would be a good one to compare this with, and check. Use the direct comparison test and see what happens.
It doesn't work.
You already know what's going to happen, but let's just do it. Yeah. Take a second and do it.
One over n with diverge. But
Well, it's bigger than
smaller.
it, so, no.
But this
It tells you nothing.
smaller.
Oh, it's smaller, yeah.
Yeah, it just doesn't
Yes,
work.
Yeah.
the mental process of the test helps you learn the test better.
What is 1 over?
I have no idea.
If you 3 plus this.
Probably
What's
like,
another thing?
1 over, wait, it's 1 over, or 1 over, it goes to infinity, it would be 0.
Well, 1 over n is smaller.
Yeah, 1 over n is bigger, or 1 over root n is bigger than
No,
1
no.
over 2 plus.
No, but 1 over, just 1 over n. Is
Yeah, 1
smaller.
over n.
1 over n is smaller. And that,
Oh, I bet you it's like,
it diverges.
probably,
No, it
I'm
diverges.
saying 1 over n to the 1/2.
No, just
probably
1
like-
over n. Think
Okay,
about it, just
yeah,
1 over
yeah,
n.
On
Yes.
the test, is it gonna
That
ask us to like use
So
a
that means that
specific
we can
test?
grade it.
No.
Oh, yeah. So we just use
Yeah.
So
whatever.
if you have a different test,
And 1
that
over
there
n.
is a different test that's easier to use with this
Yeah.
one, you can absolutely use
Okay.
it. Yeah. All right, so if
One over
you
root
use
n
the
is
first
bigger than
function, what function would you think of to use for this?
1 over
No.
1 over root n,
Oh,
right?
yes.
Now, does 1 over root n converge or diverge? It diverges based on the p-test, p-series, right? Okay, so in order for this to have meaning, then, since the function we're comparing to diverges, we would want this to be greater than that function, right? Is this always greater than 1 over root n?
No.
No, it's always less, right? So because this is always less, because you're adding to the denominator, that means that the direct comparison test doesn't work for 1 over root n. So do we stop there?
No.
No, because your homework tonight is specifically going to say use the direct comparison test, so you have to use it. All right, so you got to try a new function. So here's what I did. 1 over n was the next one that I tried, and 1 over n is tricky. Because what happens is, so you can, here's our original, right? Here's 1 over root n, which is nice, because it's always bigger. It works out really well, except the test doesn't work. So you try 1 over n. 1 over n is bigger, 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 the same,
Smaller.
smaller, 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 smaller. And if you graph it and look at it, you'll see that they crisscross, right? They are going and then they crisscross and then one always stays below. So, and you have my permission to just graph and look if you're not sure, or do a table on your calculator, right? Look at the table and just take a look and see. Scroll down. You don't have to prove it, you just have to acknowledge it, right? So, what happens is 1 over n works for n values that are greater than or equal to 4. It's okay if it's equal, it just has to, can't change direction, right? So as long as we start from 4 or higher, we can apply the direct comparison test using 1 over n. Because does 1 over n converge or diverge? 1 over n diverges, also based on a p-series, right? So because it diverges, and because this guy is always greater than 1 over n, for n greater than 4, the original function will also diverge.
Wait, so you can use, oh. you can
Guys,
use
trace is back to 4 at 1.
Play.
Could you
Okay.
use 2 over root n?
Use 2 over root n. It just makes this even bigger, right?
Why?
If you have 1 over root n and it's already bigger, if you do 2 over root
Oh,
n,
you
it's
want it
just
to be-
still be
right,
bigger,
right,
and you
right.
want it to be smaller, yeah.
So you can't do whatever, you read it?
That's actually what I tried.
Oh, you're
to
thinking
fix,
whatever
and then there
to
was
root
this
n?
cross as well, but it wasn't a
I
kind
would
of
think that the root n would eventually win over the 2, but I don't know, I have to, I don't know.
Or you could just
Look
do
at the
1 over n.
numbers. So, but yeah, you're gonna try, just try different things and see.
Good try, guys.
Alright,
Yep. I like.
okay, let's move on to the limit comparison test.
Oh, I like.
I like the limit comparison test. Yes, I know.
Seems like we get.
See, and I apologize, I'm just telling you right now, I do apologize for inflicting negativity on the test, because I shouldn't. If you like the direct comparison test, you know, please use the direct comparison
You
test.
did this the
right?
last time.
I know, I'm sorry.
It's not really that big a deal.
I know,
It's
but
okay.
You are
it's bad.
entitled to your personal
Yeah, I
preferences.
know, but it's
Unless
bad.
your preference
Ms.
is
Price,
wrong.
bias is perfectly natural. You should embrace it.
Embrace what?
Embrace the
Alliance?
bias.
Oh, bias, I guess. Okay, so, yeah, if I had to choose between the two, I have to be honest, I would always go for the limit one. So, here's what the limit comparison test says. All you need to know is that the function, your original function, and whatever one you pick that's similar, that they're both positive. And almost all of these sequences are always positive, because you're plugging in positive values of n. So the only time you would have a negative is if there's a clear negative sign in the sequence, like one of those -1 to the n's or that kind of a thing, right? So as long as they're always both positive, then you just divide them and take the limit. And if the limit exists, if it's finite and positive, then they match, meaning that they either both converge or they both diverge. So as long as the limit, you take the limit, you find a function, you have your series, you find a similar series, you divide them and take the limit. If the limit gives you a normal number, right? 10, 12, 1/3, whatever, right? As long as the limit gives you a normal finite answer, then if the new one converges, the original one converges. If the new one diverges, the original one diverges. You don't have to worry about which one's bigger, which one's smaller. You also don't have to worry about which one goes on top. That's one thing that bothered me about this sheet. I'm just gonna hold it up, holding it up for the camera, right? Is when you look at this sheet, it makes you have to think like, okay, I have an a sub n and a b sub n, and if a is the limit at a sub n over b sub n equals L, which is greater than 0, then b sub n converges, and it gets very confusing. Don't get hung up in the a sub n, b sub n stuff. It doesn't matter which one's on top and which one's on the bottom. Because either way, if the limit exists, then the limit exists, right? Whether it's 1/3 or 3 over 1, it doesn't matter what the number is as long as it's a number, right? So it doesn't matter which one goes on top. Just know that whichever way you do it, as long as you get a number, then they either both converge or they both diverge. All right, so here we go. Here's your first example. Okay, so suppose you want to determine if the sum as n goes from 1 to infinity of 1 over 3n plus 2 converges or diverges. So again, it's just like direct comparison. First thing you want to do is pick a series that you think is similar. Tell me a series you think is similar. 1 over n, 1 over 3n, it doesn't matter. Yeah, either one. Okay, so next thing you do is there's two things you have to do. You have to determine if that series converges or diverges, and you have to find the limit, right? So I did 1 over n. You can do 1 over 3n. It doesn't matter, right? So what did I do this? Okay, does this series converge or diverge?
Diverge.
It diverges, right? This is the harmonic series based on the p-series, p-test. This one diverges. So you just find the limit. Everyone take a second, find the limit of this over this. Or that over that. Either one. Wow. That's pretty quick. Well, you don't have to. If you feel like you can do it.
Yeah.
Did you
Oh,
look
so it's
at
gonna
it?
be positive, finite, and then.
So it doesn't matter.
So if you do the limit of 1 over the other, So you're just dividing, right? Keep, change, flip. So we've cleaned it up. This limit is 1/3, right? Since the limit exists and since this one diverges, that means that guy diverges too.
So what do we do if it doesn't exist?
Then the test is inconclusive.
Okay.
That's when you check calculus.
All right, so try this one on your own or with your partner.
Wait, do you like make up a function to like comparative? Do you use make up function?
First more problem is always like
So root n over
You can just say
root
compared to
n.
1 over
No,
n.
you can just do root n over root n over n squared like it.
You can just do 1 over n squared
Yeah, you're right.
over root n.
Ooh, t squared, t series.
Or you could just make it bigger
So you 1 over root n.
or smaller.
Oh yeah, because then you get 1 over.
You're dividing.
That goes to infinity, it turns into 0. So convert.
What is root n? 1/2 minus 2.
Did you tell Larry, we found this on the floor, I'm thinking it came out of her notebook.
It's really easy if you just compare to 1 over n squared.
Do it.
The answer is kind of up there.
The answer's kind of what?
It's up there.
Well, like the final answer is, so.
Oh, oops,
To be
sorry.
honest,
Oh
I
well.
like the.
That's okay. There's a quiz so that you guys peruse at your leisure. So what did you compare this with?
1 over n squared.
1 over n squared? Really? You didn't do root n over n squared?
Yeah, I did root
I did root n over n
did
Oh,
root n.
actually, root n over n squared makes it easier
Because it's 1 over
because
n.
then the roots cancel when you do the limit,
Well,
right?
I accidentally wrote down 1 over n squared over n squared plus 1. I got the same answer. No, I mean like I did it the wrong way and it ended up canceling and it still worked.
Okay,
How many
yeah,
like
you,
easier?
it will make your life easier to pick one. Usually what I do to pick a similar function is I just drop the constant, right? So, if there's a +1, I just rewrite the same function without the +1. And then what happens is, and the reason you do that is so that the limit becomes easier because things cancel, right? But first, just to figure out if this converges or diverges, you did have to clean up. So you had n to the 1/2 over n squared, so you get 1 over n to the 3/2. And 1 over n to the 3/2, of course,
That converges.
converges based on, because it's a p-series, right?
T
All right. Okay, so by the p-test, this converges, check the limit. Does it matter which one goes on top, the old over the new or the new over the old?
No.
Makes no difference,
Hey,
right?
it's okay,
Change
sir.
flip, n squared over n squared goes to 1.
I've been killing it.
Okay, that's good. All right, so one more. One more. And then 4 more. There's really 5 more. But there's one more of these, and then there's 4 more.
You built up my
Take it up a notch, guys.
It's not taking up.
Taking it up a notch.
Alright, so you can compare it to n times 2n over 4n.
Why is this here? Oh, we'll just cancel our
Yeah.
n times 2 to
Or n can take the 4.
2.
Exponential.
2n over.
So that we know diagonal.
So.
Oh yeah.
Well, what happens to the original?
No, you probably want to keep it.
The original, okay, so you know that.
I mean what happens to the compare with? Because I
You
use
can
n. I use 2n over 4n squared.
Sorry,
To compare with
you
it.
need help.
Well,
Okay, I'll go.
I mean,
2n
yeah.
over 4n
Do you need
2 over
help?
4 squared because of
Yeah, but what
compared to
is
growth rate, it diverges because it goes to
Oh, you need
infinity.
the Nth Term Test.
Yeah. It
Comparative
goes to
growth
infinity.
rate.
Well, you just use comparative growth rates there, and you know that it diverges.
It diverges, and then you do your limit is, yeah.
Yeah, we'll follow there.
It's a lot of
Study
different
hard.
varieties.
So you got a good comparison function.
Oh, so that's a good function.
Well, you could go and
Wait, did you divide it out?
What?
Like n times 2 to the n over 4n to the third plus 1 all
Yeah.
divided by
How's it going?
n times 2 to the n over 4n to the third.
Something like that.
Dude.
Is it just 1?
Frank.
Oh, okay, so it diverges.
No.
You got me? You got me?
Because
Cause he doesn't have to fill up it with any symmetry. Fourth hour open.
He's gonna next turn, cause he has 2 open.
He has 2 open things?
Yeah.
And then what he's gonna do?
Was.
Yeah, I know.
Boys.
What?
Just like the math.
Yeah, that's amazing, yeah.
Exponential is greater.
Okay, do you want?
Well, it's the first hour, cause fourth hour.
It is.
Exponential is greater
Fourth
than
hour.
polynomial.
Yeah, so 2D nth over.
It goes to infinity divergence.
Yeah, divergence, I said that.
Yeah.
I said that.
Oh,
Dude,
Emerald.
Can't he just
Emerald.
like have a nice 3
The
hour?
green emerald is, no, what is it?
so they both.
Isn't that a type of?
This is gross.
Never mind. Yeah.
No, not this one.
Isn't that type of stone?
Yeah. Like a, yeah.
No, not emerald. Emerald is like the other one.
What other one?
You know what other?
Yeah.
Isn't it?
Yeah.
Is it?
Yeah, it is.
Oh, is
Yeah.
it?
Feel like it?
Yeah, like it's like a marble or something.
Yeah.
It's like another one.
Another one. If you, yeah. See that? Yeah. See that?
Dude, I should be doing
It was your birthday the other day. 5 hours.
Yeah, I know.
Hey.
That's why I like skipping.
Yeah.
Alright, I'm glad they trained.
Yeah. Probably went to, what is it? Jay's, no?
What'd you get?
No, not brick. Kerrigan's. Share. The brick.
Would you, I use times 2 to the n, 4 n.
Yeah, well.
I simplified it to the n over 4 n squared, use comparative growth rates to get it to diverge. And then I divided them, I got 1 and like, so that it's positive.
Alright, so you had this back, let's sit down with that.
Bum, bum,
First, you want
bum.
So what did you compare this with?
Oh, no, I
2 to the n all over 4 n squared.
Or into the.
Yeah, so that's what I did too. I did n to the n over, oh, I didn't do the 4. You can do the 4 though, it doesn't matter. Yeah, over n cubed. And then I just reduced, yeah, I got 2 to the n over n squared.
Then you do an nth term test, and then by comparative growth rates.
That's what I was looking for. Did you guys all hear him? Alright,
Wait, what
so
did you say?
the big question there was, does this converge or diverge? Because it doesn't help you at all if you don't know if this one does, right?
No.
So, if you're not sure, what do you always start with? Nth term test, right? If you take the limit as this approaches infinity, the easiest way to do it is comparative growth rates, right?
Yeah.
Exponential over polynomial is going to infinity. So this diverges based on the nth term test. So, now we have to do the limit, right? So if we do the limit of the quotient, we change flip, n cubed over n cubed, so the limit exists. If you did a 4, you would have gotten a 1 here, it's the same thing. Alright? So therefore, since the, whoops, yes?
Oh, I was for a second, but, if you, okay, come back to me for a second.
So since the limit is finite and positive, right, since this diverges, this will diverge. Yes, Hannah?
Okay, for our test, do we have to list what test we use?
No. Alright. So this next screen is one that I created before I knew you had that spreadsheet thing that we handed out. So, but I left it on because I thought maybe it would be helpful to somebody. It just, it's a summary of everything we've done so far. So, sequences converge if the limit exists and diverge if the limit doesn't exist, right? So then you've got your nth term test, right? If the limit is not 0, it diverges. Your geometric series, which I think you're all pretty good with. Telescoping, which I think you're all pretty good with. Integral test, okay. P-test, which everyone loves. Direct comparison, all right, and now limit comparison, right?
Skipping over that.
Yeah, I kind of gloss over a couple of them. So going back to something. So here's where I have an apology and a clarification to make, all right? So am I allowed to say your name?
Go for it.
I'm just gonna say Dylan, right?
Dylan Zaug, everybody.
So anyway, yesterday I was telling you that when you have a sum, remember that the sum of a sum is the sum of the sums, right? So if I have the sum, if I have the sum of a sum or difference, right, then this is the same thing. Whoa.
That's cool.
as the sum of a sub n minus the sum of b sub n, right? Okay, so converging plus or minus converging is converging. That's a definite, that's a fact, all right? So if you have a series that is two separate functions, basically, two separate rules being added or subtracted, and they both converge, then the whole thing converges. Do you understand? So that is 100% true. Converging plus or minus diverging, I'm not 100%. I think it diverges though, and I feel pretty comfortable with that math. It's the diverging plus diverging diverges, but diverging, unless you have a negative. Okay, so let's just say diverging and diverging are inconclusive. And here's why diverging and diverging don't necessarily diverge, because yesterday Dylan said, what about infinity minus infinity? And I kind of scoffed and said, you know what, that's just, I literally scoffed. Yeah, so I'm using the word scoff, I'm not going to gloss over it, I scoffed, right? Okay, and then you said, no, Mrs. Price, I'm serious. And I kind of had to backtrack and say, I don't know, right? So this morning, I was looking at today's notes and I saw the telescoping. And it occurred to me that if we have a 1 over n minus a 1 over n, right, something like that, where it would be a telescoping, you'd have a diverging minus a diverging, but it would converge because it's telescoping, right? So then I went and talked with one of the other math teachers. I actually talked to Ms. Johnson, because she was in again this morning. We had a really good math conversation before school. And so we had this talk about it, and she said, yeah, it's very annoying. When you have diverging minus diverging, you don't know. So you have to use another test to determine. So for diverging minus diverging, it is inconclusive for the very reason that Dylan said yesterday, which was the infinity minus infinity thing, so thank you for that.
Maybe
So, and I apologize.
And in fairness, though, we had asked several questions previous to that were specific.
Hey, that didn't happen. That didn't have an audience.
Not totally did. So
Scoff-worthy.
it wasn't like he was raising his hand and then just like,
I did
about
raise
this,
my
and you were
hand
like,
at that time, though. I
these
did raise my
I
arrogant
scoffed at
children.
you.
Yeah.
Okay, so anyway, that being said, what I want you to do for the next 10 minutes is use your vast knowledge of all the tests you've learned so far. And we're going to do 4 problems to see if you can put it all together, right? So the first 2 are here. I'm going to give you 5 minutes to do the first 2, and then I'm going to put 2 more, and I'm going to give you 5 more minutes. All right? Okay.
The first one's diverging.
I'm almost there, so you gotta slow
The
down.
second one is just like the warm-up today. We already did it today, not the same one, but it's very similar.
Yeah.
Actually, the first one's convergent.
No,
Yeah, convergent. Oh wait, no, never mind.
it's divergence,
Yeah,
yeah.
I was mixed up. I was thinking about
That's what we do
because
though.
it's finite.
So it'd be 6 times 3 to the n times
Everything he never did, we can digress.
over 3n over 2 times 3 times.
Dude,